we've got the function capital F of x is equal to x squared minus 1, all of that raised to the fourth. So this was the first example we looked at when I introduced you to composition of functions. All right, our goal is to calculate the derivative of this function. And what I see here is that I've got fancy stuff surrounded by parentheses and a raised to the fourth power. So this is nested functions. This is composition of functions. This is more complicated than just x raised to the fourth power. So what I want to identify here is I want to identify the inside function and the outside function. And so we briefly did that when I first started to talk about this. Our inside function, that will be our g of x, which is x squared minus 1. And our outside function, which I can call f of u, or Nick pointed out is that I can also just use an x. Our outside function is stuff raised to the fourth. All right, so our derivative is going to be the derivative of the outside, keeping the inside the same, times the derivative of the inside, which means I'm going to need derivatives of both the outside and the inside. So I'm going to do a little side work here and take the derivative of x to the fourth, and I get 4x cubed. And I'm also going to take the derivative of x squared minus 1, and I get 2x. All right, so our chain rule says, take the derivative of the outside, keeping the inside the same. So I'm going to use my formula I came up with for the derivative of the outside, but everywhere that I see an x, I'm going to have my inside function. So I'm going to have 4 times x squared minus 1 to the third. So this is my derivative of the outside, keeping the inside the same. This is f prime of g of x. Times the derivative of the inside, which is 2x. That is our g prime of x. And so this is our derivative of f. All right, let's look at this second example that I introduced you to, the sine function. And so with our sine function, sine of x cubed plus 5x, we said that our inside function is x cubed plus 5x, and our outside function is sine of x. And so in order to calculate our derivative, we're going to need the derivative of the outside, so the derivative of sine x is cosine x. The derivative of the outside, keeping the inside the same. So cosine not of x, but of x cubed plus 5x. Derivative of the outside, keeping the inside the same, times the derivative of the inside. And the derivative of our inside function is 3x squared plus 5. So times the quantity 3x squared plus 5.
Professor, how would you relate that, since you're taking the derivative separately, how would you relate that equation over there?
To this one down here? So what I would do is, if I had another way to write this, I'd have my g of x function, which we're calling u, and that was x cubed plus 5x. And I also have the y, which is our f of u function. And so here I'm using sine of u, using that notation down there. So I'd have sine of u. And so when I want to look at dy over du times du over dx, I'll leave that down here at the bottom. Then our dy over du looks like, well, here's y, and so the derivative with respect to u, I'm thinking of u as my variable. Dy over du is cosine of u. And du over dx well, here's my u, and I'm going to take its derivative with respect to x, so I'm thinking of x as the variable. So du dx is 3x squared plus 5.
So it doesn't matter if it's because dy over du or du over dx.
Well, so in this first expression here, the u is thought of as our independent variable, and in the inside function, the u is the dependent variable. So when I put these two together, I've got ui over dx looks like cosine of u times 3x squared plus 5. And that's a little bit upsetting because now I have u's and x's in there, so I can go back and say, okay, well, what was u? U is x cubed plus 5x. And then I have that times 3x squared plus 5. Okay, other questions about either of these two chain rule examples? We're going to do a bunch more. Yes. All right, but we'll wait until after the 10-minute break. So take a 10-minute break now, and when you come back, we're going to do a bunch more examples.